and welcome back to another Microvellum live event. My name is Clay, and we are glad that you're here with us today. We are streaming here from our headquarters in Southern Oregon on this 13th day of December 2017. And in case this is the first time that you've joined us for one of these live events, we host these free educational sessions weekly for our users and for those who are curious about our solutions for design to manufacturing, as well as other tools and associations that complement our products in the woodworking industry. Our goal is to provide a platform for education, and we definitely appreciate you taking the time to join us here today. We are streaming on two platforms for your convenience, here on the Zoom platform that most of you are logged into, as well as our YouTube live stream. And you can ask a question at any time on either of these platforms. Here in the Zoom webinar platform, you can click that green Q&A button down there in the bottom of your navigation panel to ask the question, or just use the comments area. We like to make sure that a lot of the questions are asked primarily in that Q&A, but we liked hearing your commentary too in the chat area as we go through this today. We are recording this event, and it will be available within the next few days on our website and Help Center. And as always, if you have not subscribed to us on YouTube, we recommend that you do, so that you are notified of the future live events when we go live. All right, in case you missed it last week, we spent an hour or so reviewing the Leica 3D Disto laser system from Advanced Dimensions. And in this event, Adam Dierig helped us understand how this tool works and how, as a Microvellum user, you can use it alongside your drafting and engineering processes. It was a great event, generating lots of inquiries. And so if you want to watch the recording, it is now available on our website and Help Center. So go ahead and watch that. It was a great event in case you missed it. So today we are geared up for another Q&A live stream. This style of event is a little different than our usual weekly events. We try to host these once a month. And instead of our team presenting training on a specific topic for an hour long, we get to answer your questions or questions that we've received from you over the last month or so regarding what you might want to see or learn in the software. And so we've prepared a few answers to some of these common questions. It looks like we have a few questions coming in. Looks like the chat stream is going. Welcome back, Matthew. Always like your running commentary. And so let's see here. Let's get started here. While our team is looking at some of these questions and getting prepared, why don't we invite Shane up, and we're going to review one of the tools that we have that's available with our nesting modules. So Shane, thanks for taking the time to join us.
Happy to be here.
All right, so Run Face 6. This is a module that's been around for a while, but for those that are watching that don't use Microvellum or maybe don't even have this module, let's take a few moments and explain how this feature works. I know we've made some improvements here in the last few releases, some changes that our users should know about, so I'm looking forward to seeing what we've got cooked up here for this.
Yeah, let me get situated here, see if I can get my computer to work. Okay. Well, it looks like it's halfway working.
Mm-hmm. Yeah, we see your toolbox open.
Yeah, the one everything's not working correctly, but that's fine. Technical difficulties here. There we go. Okay, so yeah, so we made a few changes recently in the 15.5 to the Run Face 6 first module and how it works. And in the past, it is always doing that trim cut. So what Run Face 6 first is, in case you're not familiar, is on a nested sheet, anything that has Face 6 on it, typically it would cut that part out. And then you got to place that part back on your sheet after it's already done at a specific spot and then mirror it and then route it rather. So if you have a lot of parts, you could put that Face 6 thing on there several times, you know, per even on one sheet. And so now what you can do with that module, if you have it enabled, is you can put that sheet on there and it'll do all the Face 6 operations first, and then it does a trim cut on the opposite panel, the corner rather, of the sheet, and then you'd flip that part over, and the part that edge that gets trimmed will go against the pins, and then it does all the phase 5. So that's how run phase 6 first works. And we've made a few changes to it in 15.5 to allow you control, or better control, over which direction that trim cut gets made, whether it's clockwise or counterclockwise. There is some people had wanted that change. And we have allowed the user flexibility as far as which corner gets trimmed. We've tried to allow programmatically figure that out, but ended up being, we just decided it would be better just to give the user the control. And so some people, you might notice when you're using this option, well, it's not working now, it's not trimming the right corner. So what I'll show you in here is how you can control which corner gets trimmed. So in your options page, if you go to your machining tab, and then inside here, you're going to need to access the settings of the tool file via the spreadsheet. So if I open the spreadsheet, and on row 33 is user set origin. And there's some help text here as far as which corner you need to specify. So 1 for lower left, 2 for lower right, and so on. So for instance, if your sheet origin is the lower left, you'd enter 1, and then we would trim the appropriate corner. So if you're finding it's not routing the right one, go ahead and set this. And if you have nothing in row 33, all you really need is a number. You can fill out this information. This really is just for your information in column A. All we're looking in the program for is a number here in this column. And so if you do the route and you notice my trim cut is not in the right area and there is something here, then you can play with those numbers until you get it to shift around to where you want it to be, and it will work just fine. Another problem people are having is now you can flip those things around. You can change the way it routes, whether it's clockwise or counterclockwise, and some people are saying, well, now it's offsetting to the wrong side. So now my tool comp is wrong. So now there's another setting as well down here on row 130. And again, it's the same thing. You can fill out this information for the name if you want, or you can just enter here. And this is a 1 or 0. So 1 to flip it, or 1 to leave it, 0 to leave it alone, and then 1 to flip it if you need to. So using a combination of those two things, everything should be exactly the same as it was in 15.4. Even better now that we have allowed the user a lot more flexibility as far as those trim cuts go. And it should work just fine. And there is some help topics with all these screenshots written up in the forums. So if you want to go back through and you maybe want to know what this help text was again, can't quite remember it, is all in there. Maybe we can throw up a link to that in our chat section for users who want to review it later for any reason. So that is how that works.
All right, thanks, Shane. Yeah, so this is definitely a great time-saving tool, especially for those who are running bottom edge machining. Without this tool, as many of you know, we are going to provide a separate G-code file for that phase 6, or maybe we can even merge them together, but there's usually a separate phase 6 file that's generated you would have to basically run it per part and then re-index it back. And so what this tool does is it kind of takes that process away, allowing you to have one file for all of the phase 6 and then flipping it back and making these trim cuts as Shane is talking about. So definitely a great time-saving tool. If you guys are not using it and want to learn more about it, just let us know, and we can get that enabled there in your key to try it out. Okay, yeah, thanks a lot for that, Shane. So let's talk for a few moments about processing. And here to help us understand a few different areas of our processing and exporting capabilities and working with that whole interface, we've invited Tish from our support department. So Tish, how are you today?
I'm very good. How are you?
Oh, great. Yeah, thanks for taking the time out of support. I know it's a busy time there in support, and we're looking forward to seeing what you've cooked up here for us today in that presentation for this. So thanks again.
All right, no problem. So I'm going to go over a couple of things. This is mostly regarding tech support. and also workflow issues. I log into a lot of computers every day, and sometimes there's things that I have set up, but other people haven't. So I'm just going to go over a couple of those. The very first one that I have is processing center part loading. It's defaulted to manually load parts. However, I always select auto load all parts. So then what happens is whenever you open your work order.
Hey, Tish.
Yeah?
Maybe it's just me, but I don't see your screen that if you're sharing anything.
Okay.
You might want to double check that screen share. Reshare it.
What about that?
There we go. We're back in business. Thanks.
Okay. So the setting that I was talking about is under Toolbox Setup Options, under Processing. It's right here, Auto Load All Parts. You can also do auto load parts with machining. I've seen a lot of customers use auto load parts by material, and then it would immediately pop up a list of materials within that work order so you can select them. But what this does is once you open your work order, one sec, it will immediately load the parts. There we go. So then there's all my parts, and then I can just select and apply my machining or do whatever I want to do. The second one that I have is recently opened projects and work orders. Whenever you select your work orders, you can always select your recent ones. So that way you don't have to scroll all the way through your list, because sometimes customers have very long lists, a lot of work orders, and it's always handy to use this one. And then you can also do that with projects. See here, I usually do mine by version number since I'm testing sometimes. And then another one that I have is I do a lot of reports, and sometimes customers will have a huge list of reports just like this one. But whenever you're in your processing center or you're printing your labels, you only want to see one, or you only want to see a couple rather than all of the defaults that we have. One of the really awesome options you can do is you can right click on it, you can go to Setup Selected Report, and you can hide it in your report list. And what this will do is it will hide it within your processing center. Whenever you go to General Reports, you will only see those ones that do not have the hide in report list. And this also applies to the labels, to where whenever you open your processing center and you go to either select your labels or configure them to be a different type of label, you'll have a much shorter list rather than like this huge list right here. So that's kind of nice to just, it's kind of trimming it down so that way you can do less clicks and less movement of your mouse. Let's see, so that's as far as the workflow. And then this is regards to tech support. One of the most common things that we do in tech support is we ask you for some of your data. Most often, if it's a report, we ask you for your report. If it's a tool file issue, it's either your tool file or your processing station. Most of the time, it's your work order, your tool file, your processing station, and sometimes your project. So I just want to point out the difference between your tool file. Your tool file is the actual spreadsheet that you saw that Shane brought up earlier. That's the only thing that exports. But whenever you export your processing station, that exports the database copy of what you have set up in your processing station. And it also includes any settings you have. So let's see, let's do this one. No. So if I were to play with this one, I go in here. These settings are really important if we're doing any sort of testing or trying to recreate your issues, because all of these settings are going to be tied to whatever you do in the processing center. So those are a definite must that we need whenever we ask for them anyways. And then another one is work orders. So this export work order button, it kind of works. It's being worked on right now. So the easiest way that I found to export a work order is I just go to my factory data, and then I'll pull it over here. And then here we go. I have my work orders folder, and here's all my work orders. And so if, like, say I need to send it to tech support, I can just right click it, send to compressed zip folder. And then once that's done, this is the zip file that I would attach to the ticket whenever the tech asks for that. And then that way we have your information, we can test it, and we can figure out what's going on. All right, Clay.
All right, awesome. So did we cover, I mean, in the exporting there, as it relates to tech support, one of the nice features that we have in the support portal for that?
Oh yeah, so we also have the support portal. This is to create your initial tech support ticket, and you can fill out everything here, and these buttons will attach all of that information for you. So this is really handy whenever you run into an issue, and then you type it, blah, 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 and then you can attach your recording, you can attach a screen picture, processing station, and the the tool file and the processing station. And then
Right.
your work order. Mm-hmm.
So yeah, this is definitely, while you're here on this screen, this is definitely a great tool. We have as many of our users know, but if you're not a user, we have a help center that we have where people can create their tickets, and oftentimes they have to go through some of the processes that Tish is showing here for exporting some of these files, as we need to help solve tickets and things like that. But what we've done is we've created a tool that taps into that system that'll provide you a lot more flexibility to access some of these files quickly. So if you are creating a support ticket and you know that it's related to a tool file, it's related to a work order or something like that, you can come into this UI and simply click on those buttons to browse to what you want to attach, and it just comes over seamless without having to go to the website, and that goes into our support department. And if you have a video, or if you want to record maybe a process, a workflow, something you're not understanding, then you can use that option there to record the screen without needing any other third-party recording software to do that. So definitely a great tool. Many of you guys are already familiar with it. So, but if you're not a user, this is a nice tool here to help expedite the support ticket system that we have. All right. Let's look here. We have some questions coming in from YouTube, I think right now. And let's get back to, we'll get to those here in just a few moments here, but let's go back. Thanks again, Tish, for helping out with this. Let's go back to Shane. We had a question come in recently about the 2D machining tools. I think we previewed that in a previous live event a few weeks ago. But since then, we've had some questions about the differences between that UI and the 2D tools and parts list. So maybe you can give our viewers here today an explanation of the differences between those two interfaces.
I can definitely do that.
All right.
All right, yes. So we have two different tools, tool palettes, as Clay just mentioned. A lot of them are similar, and they're also very different as far as what they can do. So first off, I'll just show you both of them, and then we'll kind of talk about it. So first off, the original one, where you draw a part in 2D, and this interface comes up where you have your parts list, and then you can have this one to start placing your routes or your drills, whatever you want. And then you have this one, which is the nest editing and 2D machining tools. So there's two different ones here. This one, the original one, I'll go ahead and close this one down. This is the one where you draw a part in 2D. This one is the one you would use if you're working in 3D and you want to make a route and you want to update it, and you want to place a route here and you want to update the 3D model back. You would use this one here. There was some confusion, some users thinking that they could do that via here because you still have access to the routing tools. However, you can't update the 3D model with the 2D machining tools. This would be for editing the part, and you're going to make a one-off G-code, or you're in the nesting, or you're in a single parts, and you're going to modify it right there, and you're going to immediately make the G-code. That's where you would use the 2D machining tools. So they have different uses. And also this one here, you also have access as well. Like we've shown before, you have access to the nesting tools. So all of the things you would do in a nest, whether you're going to move a part, rotate it, make the center line, you want to change the set mills, it would all be done in this one. So again, those are the two differences. This one here, again, is mainly used for 3D, and this would be mainly used for just strictly G-code. Let's call it like that. Another thing we've just recently changed in the 2D machining tools, I'll go ahead and highlight just this one now, which a hot fix will be coming very soon with this one. You notice this one might be a little different than what you're used to seeing. The current processing station and work orders were always here, but we've kind of highlighted them because they're important. This current station, we have to highlight that one because there is some instances down here, some of these buttons, it does read settings from your station. For instance, the change border set mill, it will read the offsets and links from the station. That's the reason it's in here now versus just a tool strip item. And also the work order. This is where we've made a change. If you update something and there is nothing specified in the work order, for instance, right here, if I was to update my G-code, it would actually come up and say, what work order do you want to update? Because we don't know. There is nothing specified here. So now what we did is if I have a work order open, let me just do it for you real quick. Maybe. Hey, there we go. Now it automatically will populate this with whatever work order you have open. So if I change this work order, it will also refresh. Let's do that one. So it refreshes to whatever your current work order is open. And so that should eliminate a lot of the problems people were having with when they're updating or they're making new G-code from a nesting. It would say, what work order are you in? So asking a lot of double things there. There are some instances where this will appear as empty and it will still ask. And so if you just want to not ask anymore, simply just pick the work order you're working in and it won't do that anymore. So there's a couple of changes, like I say, that will help get rid of those things. Hopefully that helps clarify some of those two things that we had going on here.
All right, thanks Shane for that. Yeah, definitely some great tools. Yeah, one of the nice features that I like about that 2D drawing tools, the UI there when we're modifying the nests and things like that, moving parts around and making parts on the fly, it's definitely a great tool. We showed off that a little bit last week in the Leica laser tool. That was nice. So yeah, some great additions there. Okay, so let's we've got time for some more presentations on some frequently asked questions, and some of those questions have to do with some of the new features that we have in our solid modeling tool. So let's talk about that for a minute. For those of you who are using that tool, you know that's a tool that you can use to create nurses stations, reception areas, things like that. And in previous releases of the analyzer that analyzes all those parts, those solid model parts, we assign the tooling automatically for you, and in some cases that worked out okay, and in others we had users wanting to add more flexibility to be able to assign those some tooling to specific operations. So joining us today is Dominic, and he's going to help us understand how that works. So Dominic, thanks for joining us today.
Hey guys, how's everybody doing today?
Doing great.
Excellent. Okay, so one of the things that people who work with Solid Modeling Analyzer regularly requested at our recent TechCon event in April was the ability to be more specific about what tool is used for an operation type. Previously in the solid settings tab here, we had the ability to specify a max and min diameter for tools. Well, some people would have several tools that would fall under those or fall between those two specified dimensions, and some of them would be V groove bits, others would be just a hogging bit, something like that. So the way it worked previously, it would look at the size of the operation that was to be cut out, and then it would start with the largest bit and work its way down until it found one that would actually fit. And so that was good, but what we're realizing is that our users are just taking on more accountability as far as what types of things they're analyzing, so they're not going to be trying to apply tooling to something that is too small for any of their bits to fit in. So instead, we allow you now to specify what type of tool will be used for what type of operation. So I'll give you an example. Here in the tool file settings, when you're looking at your routers, you're able to specify tool defaults. This has been here for a long time for use in your library, for use in nesting or single part G-code creation. And now what we've decided to do is plug Solid Model Analyzer right into this. So you can see, basically I'm working with these first 6 routers here. My tool 101 I have set as my default router for both my normal and mirrored field. If you wanted one to spin clockwise and another counterclockwise, you could specify those here. For 104, I'm using that as my pocketing router. And then for 105, I'm using that as my border router. So these will still hold true for affecting your library and any machining that would occur through the processing center. But now this also applies to machining that's analyzed from 3D solids. So let's take a look at that. What I've done is just really simplified some operations on some 20 by 20 parts here. And I just put a circle pocket there. I'm not sure if this X-ray view is the best. Let's see if we can get something a little better. There we go. So we've got just a circular pocket. Then we've got a circular cutout. And then we have a 3-sided notch that would really normally be machined as part of the border. So as we analyze each of these, we'll see how our tool selection that we were just looking at in the tool file would select these. So I'm going to go to Solid Model Analyzer here. I'm going to pick this first one with a pocket. And so it analyzes pretty quick for us. And I'm going to draw back in our current drawing. And so from there, let's go back to our conceptual. There we go. So we see we get the same part that was modeled here in AutoCAD. So just to demonstrate, this is a solid that could be worked with. That's what that is. So in analyzing that, we got this part here, and it is an actual Microvellum product that resides in the spreadsheet. And so we can actually draw it in 2D and see what the solid modeling analyzer came up with for machining that. And so you can see it realized it was a pocket instead of a drill, and then it specified a tool to be able to pocket that out. So if we look at the properties on this polyline, we'll find out that it used tool 104. So while we've got that open, let's take a look at our tool file and see how that worked out for us. So tool 104 we had selected as our pocketing router, and that's what occurred. So let's see, this toolbar is kind of in my way for the meeting. Okay, so let's take a look at our next part. This one is actually not a pocket, it's a cutout. So we'll analyze that. And then we'll draw it to see what kind of machining the algorithms came up with. And so it automatically created our lead-ins and lead-outs and everything we would need there, ramp lead-ins, and it's using tool 101. So I won't take our time to open the tool file again, but that's what we specified as our default router. And then finally, something that would become part of the border, like this 3-sided notch here, we'll analyze that. Let that draw back, and then we will draw it in 2D. And you'll see that right now it is a separate operation. It's got the lead-ins and lead-outs. It's tool 105, and again, looking at our tool file for our routers, we specified that tool 105 was our border router. So if you were actually machining this, right now it looks like a separate operation, but by the time it goes through the include routes and borders algorithm, this will all be one smooth, continuous path all the way around, and it'll use that border. So what that does is for an end user, gives them much more control on the operation type and being able to specify a tool for that. So we're hope that it's going to make things easier for you guys instead of having to analyze something and then go back into the, instead of having to visit the spreadsheet and try to find out what aspect of this polyline you're going to alter or the tool number or whatever the case is. Now it happens automatically per your pre-specifications. So do you have any questions about that? Is there anything coming in?
Yeah, so there's some questions or comments maybe that have that maybe we should get some clarification on. Not everybody knows what SMA is, or the solid modeling analyzer tool that we've been using, and maybe how it's related to the solid modeling tools that we have. And so there were some comments about that, and how quickly we've been able to just make a product out of one of these parts. Because
Okay, cool.
you haven't even gone into, you were able to access the analyzer without even going into the solid modeling tools that we've previewed. So yeah, fully understanding the differences there between those, I think would be a good thing.
Okay. What I'll do is open up, let's see, I think I had one for tests here. The difference between solid model analyzer and solid modeling tools is the solid modeling tools prep a 3D solid for you to be able to then analyze into a Microvellum product. So we'll take something simple like this. This is just 3D solids that do not have any Microvellum logic to them. They could be drawn in another program. You could have sculpted them in here by means of something like the box command. So I can just make a box here. And if I did that and then I analyzed that, that would turn into a Microvellum product if I had material that thick. Or I could just lay down a flat panel and then only make it 1 inch tall. And then I could do things like subtract the cylinder from it to make a cutout or whatever the case is. So that is solid modeling at its simplest. But we have the ability to use these solid modeling tools. It's popping up on my other screen here. And so I don't want to go too deep into it, but to give you the general idea, these tools will allow you to model a certain type of product and then use solid model analyzer to bring it into Microvellum as a product. So if we did something, let's just draw a rectangle here. If we did something like a new custom product from a front profile, and we'll accept the defaults there. Let's see, I think we'll want to do miters here. What that does is actually build a box for me out of those 2D lines. It's got machining on it, like the miters, or the cases. And so there's two ways I could deal with this. I could use that one-off solid model analyzer button to bring that in to Microvellum as a spreadsheet-based product. Or here, I could save it as such, which just invokes the same algorithm, and it becomes a product there. So this is a really simple version of it, but what you're seeing is I use solid modeling tools to prepare a model for the analyzer to bring it in, and then it's got all the information that you need for displaying it, the information you need for miters to be able to cut that out and fit those together. So in a nutshell, solid model analyzer, although it's only represented by this button here, is actually an algorithm that scours and traverses solids in the AutoCAD environment to then produce machining instructions for that to create a spreadsheet-based product. I hope that answers your question there, Clay. If you haven't seen the custom tools, which I just demonstrated for you, they're pretty simple. You can start moving parts around, stretching them, and add machining and inserts and all different types of things. Extruded products are much more extravagant for die walls, nurses' stations, reception desks, anything, a bar in a hotel. That's what those are. We have quite a few videos on those.
Yeah, I think that was a perfect explanation of what it is and how using those solid modeling tools, the engine behind all of that is the analyzer that you were showing off in the beginning. And that the solid model analyzer tool, if you are a premium user of our solution, then that is a new feature there that we've added to that tier. So if you don't have that yet, you might want to reach out to your account manager so that you can get that module. It's a value add there if you're in that tier. And definitely, as you saw, the power of what it can do there for you outside of what we have here in our solid modeling tools. So yeah, so thanks again there, Dominic, for showing that off for us. There was another question that comes up quite a bit there, Dominic, too. Just take a minute here. Let me review it here. The question has to do with your toolbox interface there. They want to know about the Super Mario Brother icons that you have there.
Well, right now, if you want to donate to the Buy Dominic and Nintendo Switch Fund, you can just donate some Bitcoin to me through this chat here with the link. No, I'm just kidding. Yeah, so you can choose anything you want. So you can just find some icons online or whatever you want. If you so this is, I'll take a step back. So this is the custom toolbar. You can edit it from this little gear here, and then you can add a command. So maybe you do something often, and instead of having to navigate through the toolbox tabs and slides and all these things, maybe you copy a product very often. You can just select that, and it's going to appear. You see, I apply that there, and it's going to appear here. And then it will appear at the bottom of the list. So let's go ahead and click OK. And so now I have copy. So I'll be able to copy a product quickly. So along with that, we gave the ability to customize icons. So maybe you align a product quite often. You can browse and find an icon. I don't think I have any on my hard drive right now, but you just find an ICO. Yeah, I don't have any. Or JPEG, it looks like, and you bring it right in and you hit apply, and then it will appear there. So if you know what Mario 3 is, you're very familiar with redrawing selected products. But that's pretty cool because, you know, we do our best with these icons, but you look at this and say, well, that doesn't show me copied product as well as I would like it to. That's just kind of a general copy, maybe of a document or something. Then you can make your own little icon and apply it there. And if it quickens your work pace, then that helps you out.
All right. Thanks for that.
Yep.
Okay. Let's move on here. We've got some questions I want to make sure that we address here. It's often that we receive questions prior to this event, and we did receive some today. Before the event, there were some questions came in from Dan and from Nick and some others that they had several questions in here actually. And so we've managed to get some time here for one of our team members here up in Canada, actually, Tim Skolman, who has prepared some answers for you, Nick, on some of your questions. And so Tim, thanks for joining us today.
Hey, thanks, Clay.
Yeah.
So one of the questions that Nick brought up was around bay positions. And so Microvellum has all of these sub-assemblies that you can insert into products, and they're very powerful. And when you're working in a product starter, you grab a starter out of the library and place that in, and it just works, and you see what happens and things appear there. But sometimes you want to get in a little deeper and see exactly how that structure is working. And so that's what Nick's asking about. And so he was asking about the bay positions that we use. And so when you're looking in the prompts interface and you go to a product like this and you're adding those items in, if you're in the subassembly interface here, you might see that there's a column called bay position, and that has some numbers in it that vary based on where the item is located here. And so Nick was just asking where those numbers are coming from. And so those numbers are actually fairly arbitrary. They've been chosen by our library developers. as the numbers to represent different items. Really, the purpose of the bay position is to give you the ability to have the same subassembly used in multiple locations but drive different information about it. So for example, I have in this product, I have this series of bays, and the bays are numbered 71 to 79, and so 71 was chosen as the top number, and there's some reasons for why that was. You'll see 70s, 80s, 90s as some drawer inserts, and you might see some 1, 2, 3, 4s as some other items, and so those numbers are really just used to drive different things into the bay positions. And so here, if I go to this 3-drawer insert, for example, inside of there, I'll see some additional subassembly items. And here you can see that I've got 3 standard wood boxes, but each of them actually behaves differently, because in the product prompts, I might have chosen that the top drawer is going to be, a Bloom undermount drawer slide, and the second drawer might be an Aventos, and the third one might be an Antero. And so I can still use the same drawer subassembly in order to drive all that information, but it's going to read different information based on that bay position. So for most of these, when you go into the subassembly, if you look inside of them, you might find a lookup table here. And so if I go to this lookup tables, you'll see there's a list of what these bay positions are. And so in this case, I've got some bay positions, and for the left side, they're half overlay if the bay positions are 2 through 10. So that means that those bay positions are off to the right in the cabinet. It's not the far left one, because that one's going to be a full overlay, but everything to the right of that is going to be half overlay. And so the same thing you'll see for the right overlay. And so throughout the software, inside the subassemblies, you'll often find lookup tables like that will help you understand what those numbers represent. And then there's also a lookup table in the globals called lookup table bay position. And if you look for that one, you'll find the information about those bay positions in there. All right, so that was one of the questions that came in here. One of the other ones was, how do I add machining to a part? So I just threw in a couple of parts here just to show how that would be done. So there's lots of different ways that you can add machining in, and so some of that is by drawing parts out in 2D. Others are by going into the part properties or even into the spreadsheet and adding those tokens in. And so here, if I go to the part properties on this little miscellaneous couple of parts that I've put together here, that'll open up my part properties interface, and I'll see the components that are inside of there. And so when I look at that, when I'm working in part properties, you can see it highlights. So this is my left, and this part here, when I highlight that, that'll highlight, oh, that's my bottom. And this part here is my left here, and so when I click on those, it highlights and it shows me where the positions are for those. I can also highlight and do things like show part base and machine point, and so that's something that often comes up when you're building a custom product. How do I determine where the base point, where the part is referenced inside of that subassembly or inside of that product? And so here you can see it illustrates where the base and machine points are. Also for the edge banding, now I've got these couple of parts that I've tossed in here. How do I know which edge is the one that I want to edge? And so I can do things like here, right click in here and say show this edge. So if I wanted to put an edge on the bottom, then I could know that this is the field that I need to put that in. And if I'm edging the front, then I can select on there and say I'm going to put 0.01 white mel on that edge there. So the same is true when I'm going to add machining tokens as well. So if I said, I want to add some machining into my bottom panel, I can go to my machine tokens here and I can say add. And if I wanted to do some drilling on the phase 5, for example, I might just use a single drilling operation here. And so here I can specify phase 5. And so phase 5 is going to be the main machining phase that happens in the parts here. And so when I specify my machine point, whatever face that machine point is on, that's where that machining is going to come from. And so here I'll say that, I want some drilling on phase 5. And then I can specify that, I'm going to start 1 inch in X and Y, and I can give it an end dimension as well. So I can say, I'm going to end over here at 10 in X, and we'll say 10 in Y as well, and I want 1.25 between those holes. And if I save, close, and redraw there, you'll see I've got my series of holes drilled into that item there. So that's if I'm adding machining to that particular part there. And I can do the same thing for edge machining as well. So if I wanted to do some horizontal dowel holes into the edge from one part into another. A lot of the machining that we have in Microvellum is called associative machining. And so what that means is that if I need to drill dowels for my bottom panel, and I'm going to machine those into the left side, then I'm going to add that machining onto my bottom panel so that whenever I move my bottom panel, the drilling is going to come with that. And so here I'm going to say add, and we'll just say construction holes type 1 and add that in. And so we'll say that my first hole is going to be 25 back. My last hole is going to be panel width minus 25, let's say. Obviously, I can look to the size of those parts with the panel underscore width. And sorry, I'm in Canada, so that's 25 millimeters. So we'll change that to -1, and we'll do 1 inch back on that part as well. Edge bore depth, edge bore diameter. So I can certainly reference these by going in here and saying paste name, finding something from my globals for dowel diameter and that sort of thing. Or I can just say this is a one-off item, and I just want to specify that I'm going to drill a 0.5 hole in there into the side of my part where I want to drill it from the opposite side, what have you. And so for these ones, when I added it, it asked for a face as well, and I ignored that. But if I wanted to change what face it's assigned to, I can right click and I can say select an edge. And so when I do that, a little box pops up, and I think it's popped up on my other screen there, where I can specify which edge is actually going to be represented there. And so when I do that, then it'll highlight, just like it did for the show edge banding, it'll highlight which edge is going to be machined, and I can specify which one that is. And so in this case, I know that that's construction 3 because when I clicked it, it highlighted it. And then I can go apply my machining and say save, close, and redraw. And then I have my machining coming in for that part. And the nice part here about associative machining is that if I go to modify parts here and say I want to just move that part, so I'm just going to move this part manually and say I'm going to move it up by 3 inches, then my associative machining is going to come through with that, so I can see my dowel holes follow through on that part as well. So that's how I can assign the machining through the part properties. I can also do that through the spreadsheet. So if I'm in my edit design data, I can go in and see that as I added those machine tokens, those are added into the right-hand section of my my operations here. So I can see there's my drilling operation for the phase 5 boring. And there's my edge drilling for my construction hole 3 with the parameters in there. So you can certainly add them in either place. If you do it through the part properties, there's a little more explanation of what each of those is. But if you're doing a lot of copying and adjusting of machine tokens, you might want to do that in the spreadsheet as well. So that's a couple of ways that you can add machining tokens. And then we also had a question come in about MDF doors. And so if I had a panel and I wanted to add some V-grooves to that panel and make up a door here, how would I go ahead and do that? And so for that one, I'll just go draw it in 2D. I could certainly do it the same way using the part properties to add those machining tokens, but in this case, I'll just show you how I would do that as part of drawing it in 2D. And so I'm going to draw that part out, and that's just going to give me a 2D AutoCAD drawing of what that part is looking like. And I cheated there. I went ahead and I had already added those in. So let me just get rid of that for a second, and I'll just go from scratch. So we'll say that the part didn't have any machining on it, so I just want to draw something. So I'm going to draw a rectangle and offset that by 2 inches to represent my stiles and rails on the outside of my part there. And so I'll just get rid of the original one that I offset there. And then I'll say I want to draw some grooves. The customer was looking to add some bead groove lines to the face of the door as well. And so then I can offset that line a couple of inches, so we'll say that's going to be my door, and now I'm going to assign some tooling to that. And so here I can go to my 2D machining tools and go to my routing tools here, and I happen to have a V-bit already assigned in here, and this V-bit actually has a drawing assigned to it as well, so when I draw that, it's going to draw up with that V profile. And so here I'm going to say I want to make that other depth of 6 millimeter, sorry, I'm going to do that as 0.25. To 0.25 inches, and we're going to say that's center line compensation. I could certainly run that on any direction, but I'm just going to say it's center lined and grab those items. And the program's automatically going to assign set mill and start location for that routing. And so there you can see it's routing around that part. Now for something like this where I want to make sure that it comes out exactly how I want it to, I'd probably go into my route editing tools and say change my set mill location, so change where that ramp is coming in, and so I'll say it's starting there, and I might go in and say I want to add not an arc lead in that case because I don't want to damage the part here, but maybe I want to add just a ramped lead in here, and so I'll say add a lead in to the polyline, and I can just say that's about that long, and add a lead out here and lead out there. And I could do the same thing for these ones so that I didn't damage this edge. I just bring my lead in back in this direction so that it went in, turned around 180 and started coming back, and then on my lead out do the same thing. And so now when I have this part, I've got my machining added to it, and I can update part and redraw the product. And that's going to represent my my door panel there with the V-groove cutouts in it.
All right, thanks Tim for that. I went ahead and launched our performance poll. If you guys can help us out with letting us know how we did today, we'd certainly appreciate that. And I have a few more things here to cover before we wrap it up for today. Let's see here. So just a quick note about next week's live event. We will be spending an hour or so with our Australian techs as they review the latest advancements found within the product library that we have over there in Australia and New Zealand. For those users who are here in the US and Canada, the Australian library works a little bit different than the US libraries. They customized it to suit their needs over there, changed and modified the products. Let's see here. I think that's about all that we had for today. I'd like to thank you for taking the time to participate today, and we will catch you on our next Microvellum live event.